Welcome to our video on Agda, where we're going to explore how to use pattern matching to prove identities. If you're interested in formal verification, type theory, or functional programming, then this topic is definitely for you. In this video, we'll dive into the world of Agda and show you how to take advantage of its powerful features to write more concise and expressive proofs. When working with Agda, one of the most common tasks is proving identities. These are statements that assert two expressions are equal, and they're a fundamental building block of many mathematical proofs. However, writing these proofs can be tedious and time-consuming, especially when dealing with complex expressions. This is where pattern matching comes in, a technique that allows you to specify how an argument should look like, making your proofs more efficient and easier to write. In this video, we'll answer the question, how do I use Agda to prove an identity when my arguments have a certain pattern? We'll break down the concept of pattern matching, provide examples, and show you how to apply it in practice. By the end of this video, you'll be able to write more effective proofs and take your Agda skills to the next level. So, let's start with the basics. In Agda, when proving an identity, you typically want to show that two expressions are equal. However, these expressions can have a specific structure or pattern that you need to account for in your proof. This is where pattern matching comes into play. Pattern matching allows you to specify how an argument should look like, making it easier to write proofs that depend on the shape of the input. To illustrate this concept, let's consider a simple example. Suppose we want to prove the identity of B0E for all natural numbers R. In Agda, we can use pattern matching to specify how the argument should look like. And we might write something like, if A is of the form N1, then this tells Agda that we want to consider only those cases where aha has a specific structure. In this case, being one more than some natural number. Then, once we've specified the pattern, we can proceed with the proof as usual. However, by using pattern matching, we've made our proof more focused and easier to write. We're not trying to prove something about all possible values of, but rather only those that satisfy a specific condition. Pattern matching is particularly useful when dealing with complex data structures or recursive functions. By specifying the shape of the input, you can avoid having to consider cases that are irrelevant to your proof, making it more efficient and easier to understand. To summarize, we've seen how pattern matching in Agda allows you to specify how an argument should look like when proving identity. This technique makes your proofs more focused, efficient, and easier to write. The error, or pattern matching, is a powerful feature in Agda that enables you to specify the shape of argument. By using pattern matching, you can make your proofs more concise and expressive. Pattern matching is particularly useful when dealing with complex data structures or recursive functions. That's it for today's video on using pattern matching in Agda to prove identities. We hope this explanation has helped you understand how to apply this powerful technique in practice. If you have any questions or need further clarification, please don't hesitate to ask in the comments below. Don't forget to like and subscribe for more content on formal verification, type theory, and functional programming. We'd love to hear your thoughts on this topic. What are some common use cases where pattern matching has helped you write more efficient proofs? Share your experiences with us and let's keep the conversation going. Thanks for watching, and we'll see you in the next video.